Hey, this is Jane, and welcome to Jane Course video. In this video, we are going to talk about one of the central questions in cognitive science. When different kind of minds can perform the same task, what does it actually mean? Cognitive science tries to explain this question by studying how cognition works in many different systems. And today we're going to take a look at the symbolic systems, the connectionist systems, and embodied cognition. Imagine this, you, a bee, and an autonomous car, let's say Tesla Autopilot, all manage to get from your home to your school successfully. You all navigate through the way that include avoiding obstacles, adjusting routes, and reaching to your goals. But are you really doing the same thing? If different agents like humans, animals, and machines can all perform the same cognitive task, does that mean they're thinking in the same way? Let's start with the earliest and most logical way of explaining thought, which is the symbolic system approach. In the 1950s, when computers first appeared, scientists began to wonder, could the human mind be also a kind of computer? According to this view, cognition is a symbol manipulation.
So our mind actually works like programs. They process internal representations using logical rules. Let's say you are walking somewhere. So in your head, you must be thinking about if the light is right, then stop. If you want to go to the main street, then turn left and then go straight for 2 blocks and something like that. This is the rule-based reasoning. It's like if-then operations. And the early AI systems worked in the same way. They were called the expert systems, built on thousands of handwritten rules like if condition A and B are true, then C. They didn't learn, they just followed the logic. And this period is also called the good old-fashioned AI. In symbolic systems, cognition is clear and structured, meaning that thinking itself is computing rules on symbols. But there's the issue. Humans aren't always logical. We sometimes rely on our intuition, our habits, and the context. Let's say when you suddenly recognize a familiar street without even thinking, without even consciously aware of that, the symbolic model starts to break down. As neuroscience advanced, researchers discovered that the brain doesn't really operate like a computer running code. Instead, it functions as a vast network of neurons. It is composed by billions of tiny units, and each connected and changing over time. So this insight inspired the connectionist approach. In the connectionist view, thought is understood as the pattern of activation across a network of symbol processing units. It's like neurons in the brain or nodes in the artificial neural network. These systems don't rely on the explicit if-then instructions, but instead they learn from their experiences. They adjust the strengths of their connections, which called weights, based on the feedback from the environment. For example, when you recognize your way home, you're not retrieving a list of rules about when to turn left or right. Instead, your brain simply activates a familiar pattern of neuron connections built from your repeated experience, which is like you go back from your school to home for the past 3 years, and you already have that experience. The same logic also applied to be or a self-driving car. So each system have developed their internal patterns through learning or evolution that map sensory inputs like visual cues or GPS signals to appropriate navigation actions. And then the modern AI systems like Waymo's self-driving cars work in a similar way. They don't rely on explicit programming for every scenario, but instead they process millions of examples, which are the images, routes, and sensor data. And then they adjust their internal weights until they can predict the right response for each situation. In other words, they know how to drive, but they don't necessarily understand what a road means. This is the heart of connectionism, cognition as distributed learning rather than logic itself. And both human brains and neural networks rely on pattern recognition. Thought emerges from dynamic interactions of many simple parts working together. But this leads to a very fascinating question, which is if a neural network's input and output look just like ours, is it truly thinking? or merely imitating thinking. That's the challenge connectionism invites us to consider, which is to understand not just how systems behave, but what it means to think at all. Later, cognitive scientists propose a more radical view. Maybe thinking doesn't just happen inside the brain, it is the framework of embodied and extended cognition. In this view, cognition is not just internal information processing, it's a dynamic interaction between the brain, the body, and the surrounding environment. Let's take navigation as an example. When you're walking through an unfamiliar city, you don't rely entirely on a mental map inside of your brain. You look up at the street signs, you feel the direction of the sun sometimes, and you adjust your stride, avoid people around you. Your body, your senses, and the physical world all contribute to how you think. Together, they form an extended cognition system. In other words, your thinking extends beyond your brain. Your phone's GPS, the landmarks you see, and even the sunlight, they all help you think your way through the world. While bees work the same way, they don't store a detailed map or compute coordinates. They use the sun's position, sun trials, and magnetic fields. A bee's navigation system isn't symbolic or computational. It emerges from its tight coordination with its body and surroundings. What about self-driving cars like Waymo? Their bodies are made of cameras, renders, GPS, and real-time feedback systems. Without these sensing tools, the car can't recognize or respond to anything. Its mind isn't just the software, it extends across its perception action loop, which is sensing the world, interpreting it, and acting in real time. So, what does embodied cognition tell us? That thinking is not just a program run in the brain. It's a dance between the body and the world. Cognition emerges from the co-regulation between the agent and its environment. In this view, to think is to move, feel, sense, and act in context. So now let's return to the big question. If different agents can perform the same cognitive task, are they doing the same thing? Symbolic system says maybe yes, if they use structured internal rules, while connectionist system says no, they might reach the same outcome through very different internal patterns. And then embodied cognition says the question itself is too narrow. Thinking is not just inside the agent, but spread across the world by the interactions. Now, let me introduce you some of the other concepts in cognitive science that might help you understand this question. So, in philosophy of mind, functionalism claims that what makes a state mental is the role it plays in the systems, not a particular material that it's made of. So, on this view, if two agents share the same functional organization for a task, they could, in principle, share the same kind of mental state. While multiple realizability push it further, it's saying that the same cognitive function, like navigation, can be implemented in radically different physical substrates, like human neurons, a bee's compact neural system, or a silicon-based AI system, as long as the relevant cultural roles are preserved. However, the understanding versus stimulation distinction challenges the idea that functional or behavioral equivalence is enough. A system may stimulate the right input-output profile without processing the same semantic understanding or phenomenal consciousness as human. While my stance is that task-level functional equivalence might not guarantee identity of underlying computational process or subjective experiences, which is in turn qualia. It means a person or a system's subjective experiences. So in short, they may have the same outcome, but they have different process, have different experience, which you might never be able to know because we can never enter the other system's mind. And which means that they may have different minds. But this is only my point of view. If you have any other thoughts, feel free to comment.